Hello, I'm Katharina Hundenburg and I'm working on root-to-shoot signaling of potatoes under drought stress. Strigolactones are a group of hormones that are produced in the roots mainly and have recently been associated with stomatal closure, so they seem to be a likely candidate for signaling of drying soil. However, there hasn't been a lot of research in agricultural crops. So, to find out if they play a role in drought stress responses of potato, I worked with 3 different genotypes. We have a genotype that is impaired in strigolactone biosynthesis, one that is impaired in strigolactone signaling, and one that is enhanced in strigolactone signaling. And I've compared them to the wild type. On the poster, they are all color-coded, and on the left-hand side you can see a diagram of strigolactone biosynthesis and signaling with the same color code, so you can find out where they are impaired. In the experiment, we dried the plants for 6 days. You can always see the closed symbols are the well-watered plants and the open symbols are the drought-stressed plants. They all dried the soil out very similarly. This is the first line of graphs. In the bottom row, we have the leaf water potential in minus megapascals and the stomatal conductance on the y-axis. And we can see that we have at leaf water potentials close to 0, we have a range of different stomatal conductances. So leaf water potential does not regulate the stomatal conductance in this range. However, strigolactones don't seem to regulate that either, because in none of the 3 experiments are the mutants any different to the wild type. So that is a bit surprising, because previous studies found that under well-watered conditions, which is a leaf water potential close to 0, that lotus, tomato and Arabidopsis have a higher stomatal conductance when they are impaired in strigolactone biosynthesis. So we would expect, at least in this experiment, to see a difference between the 2 genotypes, but we don't. So the question is, why is that happening? I currently have 2 hypotheses. A, the change in stomatal conductance is due to the different stomatal densities in the different genotypes. Or B, the strigolactone impaired mutants produce more ABA via a feedback mechanism, and that then results in the same phenotype as the wild type. These are my ideas how to proceed with the topic. If you have any questions or comments, I'd be happy to hear from you, either here in the poster session or via email. My address can be found in the top right corner of the poster.